Welcome back, and we are beginning a new section or a new unit. This one is on quadratics, and you did quite a bit with quadratics in Algebra 1, but we wanted to delve a little bit deeper into quadratic functions here. Some of it might be review for you, and that's great. Some might be new, and that's good too. So what makes a quadratic function a quadratic function? First off, a quadratic function is a power function, and the highest exponent on that quadratic function is a 2, so we've got a squared. And quadratic function written in standard form is ax squared plus bx plus c equals 0, where a is greater than or equal to 1. So that x squared term has to be in the function in order for it to be a quadratic function. So the quadratic term is the first one, ax squared, the one with the squared power. The linear term is the middle term, bx. We have an exponent of 1, and the constant is the number hanging at the end without a variable. Now, the domain, and if we remember, what were our restrictions on domain when we looked at those? We were looking for two circumstances that would cause a restriction on our domain or our input values. If you remember, we were looking for square roots and where we had a variable in the denominator. And since we don't have either of those situations with a quadratic, usually the domain is all real numbers, meaning we can put anything we want as an input value. There aren't going to be restrictions. Now the graph, if we remember, the parent function was f of x equals x squared, and its general graph shape was this, a parabola. So in quadratic functions, the graph is a parabola. Now, the axis of symmetry is a line that divides the parabola into two parts that are mirror images of one another. Let me change ink color here. So if we look at my graph of this parabola, the axis of symmetry is the line that divides that parabola into two equal parts. It's a vertical line that divides my graph into two equal sections. And if we think of that and it's on paper and we fold on that red dashed line, the two sides are going to meet up exactly. So we can fold that parabola in half and have the two sides match up. That's what I mean by mirror image. Now the vertex, that's an R, V-E-R-T-E-X, of a parabola is the point at which the parabola intersects or meets the axis of symmetry. So let me draw another picture of a parabola here on the side so we can demonstrate some of these. I kind of lost that when I moved my screen. So here is my parabola. Looking at this, my axis of symmetry is right here. Now this one doesn't go through the origin. So the axis of symmetry is where the parabola and that line meet, or right here is the point, which would be the vertex the vertex is where that axis of symmetry and the graph of the parabola intersect. Now the axis of symmetry of a quadratic function is always, and we talked about this, a vertical line defined by the x coordinate of the vertex. So in this case, my vertical line is defined right here by that. So if this is at 1, my axis of symmetry is x equals 1. Okay. So each point of a parabola has a corresponding point on the mirror image that is the same distance from that axis of symmetry. What that is saying is if I have a point here that's 1 or 2 places from the axis of symmetry, I've got a corresponding point on the other side that is the same distance away. Now let's look at the example down below. First off, it says to identify the vertex, the axis of symmetry, and the corresponding points, or the points that are going to be on the other side of the parabola. So first off, my axis of symmetry is that line that divides it right down the middle. I should grab a different color pen here because that's not showing up. So that looks like my axis of symmetry is that is at the point 0, 2, so the line is x equals 0 for that axis of symmetry. Now the vertex is where my axis of symmetry and the parabola meet. I'm going to change pen colors again, and that seems to be right here. So that vertex is going to be the coordinates of that point, which are 0, 2. Now, it asked me for the corresponding points. Looking at the graph, I've got points Q and P. Q looks like 1 unit from the vertex. So if I go 1 unit from the vertex this way, so P, the point on P is 1, 3. Its corresponding point, I'm going to name it P sub 1. Here, P sub 1 is negative 1, 3. Let's look at Q. The coordinates for my point Q are negative 2, 6. That would be 2 left, 6 up. So this is 1, 2 spots, 2 units. So I need to go 1, 2 units over here to find its corresponding, and let's name that one Q sub 1 as well. That point is a positive 2 and a positive 6. So for each point on that graph, there is a corresponding point on the other side, meaning you can split the graph into 2 sections, fold that paper right on my axis of symmetry, and the 2 sides will match up exactly. Please pause the video now and try example 2. Restart the video when you're ready to check your answer, and I'll take care and finish erasing the board while you're starting the problem. Well, let's see how you did. We need to identify the vertex, axis of symmetry, and that's always a vertical line, and it will be written x equals whatever the x coordinate is on that vertex, and points corresponding to P and Q. P and Q. So we've kind of written that out. First things first, let's go ahead and try and find that axis of symmetry. Where is my line that would divide this into two equal pieces? And to me, it looks like it's right here at 2. So my axis of symmetry is x equals 2. Now my vertex is the point where they intersect, and that's right here. The coordinates of that vertex are going to be 2, and looking over, that looks like -6 to -6. Let's look at P and Q. Let's do P first. The coordinates of P are 0, -2. So P sub 1 for its coordinating point. We have to determine how many units is it away from that axis of symmetry. It's 1, 2 units over. So I'm going to be 1, 2 units over, which is going to put me at 4 for my x coordinate and -2 for my y. Are you noticing anything about the coordinates for those coordinating points? Specifically, excuse me, the y coordinate here. They stay the same. That's excellent. Absolutely perfectly right. So if we look at my coordinates for Q, I am at -1, +3. So the first thing I know for Q sub 1, what can I write in without even figuring how far over it is? I know that my y coordinate is going to be the same. Now we need to determine how far over it is. So here I have 1 to the y-axis, 2, 3. So I'm going to go 3 from 2. 1, 2, 3. And that puts me at 5. I hope you did well with that. I know it's an introduction to parabolas and quadratic functions. We're going to move on in the next video to finding the equation when we're given 3 non-collinear points, 3 points that aren't in a line. So if you have any questions on this, bring them with you to class next time we meet, and we'll go over some more. And as always, we